Bismillahirrahmanirrahim, dear students. This is Pakistan International School Type, and now starting grade 12. This is grade 12 and lecture number 31 and chapter number 16 we are doing. Now in the last lecture I told you the nomenclature of alkanes. Nomenclature of alkanes. And I told you there are two types. One is name structure and other is structure to name. Suppose we have names, then how we give the structure of the organic compound. Just like I am going to write here. Three methyl hexane. 3-methyl hexane. Rule, you have to obey the rules for the nomenclature. 3-methyl branch, X stand name, number of carbon atoms. N suffix means nature. X 6, 1, 2, 3, 4, 5, 6. Longest chain 6. Numbers this side or that side. 1, 2, 3, 4, 5, 6, like this one. Right longest chain, continuous straight 6. And single bond. Then 3. This is a 3 carbon methyl. Like this one. And satisfy the balance. Three-methyl hexane. This is the simple name for this. Now suppose you have two 4 di-ethyl pentane. Dear students, very important that if you know the rules how to give the name of organic compounds, then you will not make a mistake. Sometimes this question in your book, sometimes examiner will give you a wrong name. He will assess you. So that you have to draw that according to this wrong. And you have to make correction in and write correct the name. This name may be correct, may be wrong, I don't know. When I will draw, then I will see the rules for the nomenclatures. If it's satisfied, then I say it's okay. But if the rules not obeyed, then this structure is incorrect. Then make correction. Okay? Same pattern already I told you. Pen means 5 carbon atoms. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. And single bond. He said 2,4-diethyl. 2. two. Two carbon. It means two carbon. On the carbon number 2, there are two carbons. 1 and 1. Ethyl. On 4, you can put up if you have a gap, space. CH2, CH3. So this is the structure of the organic compound which is given by the examiner. And he said that if it's correct according to rules, it's okay. But apply the rules, if it's not okay, then you have to correct it and write the correct structural formula for the given organic compound. So dear students, I have to rewrite this. See this one. Count. Starting from here. CH3, CH2, then CH, and there is CH3 here. Means you can put CH3 here. Then CH2, and then CH, and there is an up or down, which is your choice. Then CH2 and CH3. Write in this way that you will feel easy to select the longest carbon chain. Now, longest will be different. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. From all directions you have to see to make the possible longest chain of carbon atoms. So possible is 1, 2, 3, 4, 5, 6, 7. From this side you can start, from this side you can start, you get 7. Now, okay, 7. But you are finding 1, 2, 3 on the carbon number 3, there the branch. Start from here. 1, 2, 3 on the carbon number 3, there the branch. It means that on both sides, left and right, equal distance. Branch on the same carbon atom. So it is your choice to give the numbers either sides. 1, 2, 3, 4, 5, 6, and 7. Different. Here was a pen and here the hat. It means this name was incorrect. This structure is incorrect according to this one. So now the correct name of this compound will be 3 and 5 dimethyl heptane. This is the correct, this is the wrong. Like this. Draw as it is, which is given in your question paper. Then think rules. Longest carbon chain select. See the branches, groups which are attached, and lowest carbon you have to select. How many branches are going to be attached? Accordingly, you have to give the name. Then you will be able to draw the structure of an organic compound. One more I will give you, then you have to solve yourself. write this, must write. You have to write this. One more is given. There are many. Suppose I am writing this one. Three dimethyl 5 dimethyl heptane. So 3,3-dimethyl 5,5-dimethyl heptane. Hep, 7 carbon atoms. 1, 2, 3, 4, 5, 6, 7. Numbers 1, 2, 3, 4, 5, 6, and 7. Now, according to this, 3, 3. This is a 3, 1, and here 3, 3, and 5, 5. Now this one. Bond between carbon, huh? Always remember. CH3. No need. 4. CH2. No need. CH2, CH3. Okay. Now students, on the 3-methyl, on the 5-methyl, same. Add different groups, branches are same, all are methyl. Then why we separate them? Same groups are linked with carbon atoms, so you have to write collectively. All methyl groups. So that this is the wrong name, and correct name I am going to write 3, 5, 5 tetra methyl heptane. This is a methyl group. This is a methyl group, this is a methyl group, these are same. All same, position different. So collectively all. 3, 3, this one. 5, 5, this one. 1, 2, 3, there are positions. 1, 2, 3, 4. Tetra, methyl, heptane. So dear students, if you know the rules, then it is very easy for you to assign the numbers and also select the longest chain, and you will be able to write the correct name of the organic compounds and draw the correct structure of organic compounds. Very important this one. Now here is the physical properties. You can read. First 4 carbon atoms for alkanes are the colorless and odorless gases, and 5 to 17 they are colorless and they are odorless liquids, and from 18 onwards they are solids. Alkanes, they have non-polar covalent bond, carbon-carbon and carbon-hydrogen, very small distance of electronegativity. They are non-polar, weak polar, and they are insoluble in water in the polar compounds but soluble in the benzene, ether, carbon tetrachloride. Boiling point is vary from the one carbon to other carbon. Longest chain increases, the boiling point is going to be increased. So a boiling point increases by 20 to 30 degrees centigrade by the CH2 group. We've done the homologous series already, I told you. The structure I told you: methane, ethane, propane, butane, pentane. and also isomers. Butane has two isomers. One is called N-butane and other is called isobutane, and you can see the boiling point for the N-butane. That is minus 0.4 degrees Celsius, melting point is minus 139. But if you write the isobutane, so when the branch is there, the straight chain is decreased. The straight chain before was 4, now straight chain is decreased into 3. So definitely melting point is going to be decreased minus 161, and the boiling point also decreased minus 10.2 degrees Celsius. Pentane has three isomers, N-pentane, isopentane and neopentane. So you can see the boiling points and melting points of these organic hydrocarbons. Highest the longest chain, higher the melting point and boiling point, you can see the difference. So alkanes are called paraffins, less affinity for the chemical reaction due to the non-polarity and due to the sigma bond present. Unreactivity, paraffins, they are not going to react with acids, oxidizing agents under normal conditions. Because I told you carbon, hydrogen, carbon bond, they are non-polar and the sigma bond is there. In our test written here, same reason, sigma bond is tightly bonded between the carbon atom. Lot amount of energy is required to break this bond, and also not bond can neither attack on the electrophile and nucleophile. We will discuss on the next chapters, electrophile, electron loving, nucleophile, nucleus loving. We will discuss later. Non-polar bonds, electronegativity is a very less indeed. 2.5 for the carbon and 2.1 for the hydrogen, only 4 difference negligible. So that's non-polar in nature. So due to the non-polar in nature, alkanes do not react with oxidizing agents and acid, and strong sigma bonds present between the carbon and hydrogen. So that's why they show less reactivity towards the oxidizing agents, acids. But using suitable conditions, they can react. These two suitable conditions are thermal and catalytic reactions and substitution reactions. So these are the two conditions in which the alkanes can react. Cycloalkanes, cyclopropane, cyclobutane. Another type of organic compound, they have a single covalent bond with the sp3 hybridization, closed chain hydrocarbons. We call cycloalkanes, which are fairly common in world organic chemistry. So man-made and natural also. So if you have this is cyclobutane. If two alkyl groups are going to attach, total 4 carbon atoms, starting from this side, where the group here start are from this side. Don't go this side, no. Okay, 1, 2, 3, 4. So 1, 2, di, methyl, cyclo, butane, like this one. Cyclopentane. Cyclopentane, give double bond. Cyclopentene. Cyclopentene. Or starting from here, 1, 2, 3, 4, 5. This will be one cyclopentene or cyclopentane. So only one double bond is here. In between 1 and 2 carbon atoms. Cyclopentene. So this is another unsaturated hydrocarbons you have here. Like this, unsaturated cyclohexene, there is a double bond. There is a double covalent bond between the carbon atoms, or you can put here also. So double bond is here. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So if I start from here, 1, 2, 3, 4. And this is the 1, 2, 3, 4, same distance. Same distance. So branches are nearer from this side. Or if you start from the double covalent bond, this is the double covalent bond, this carbon is a 1, 2, 3, 4, 5. So this is one possibility. There is the double covalent bond you are finding here. So start from where the double bond is nearer. So double bond is in the carbon number 1 here. So 1, 2, 3, so 3 and 6 dimethyl 1 cyclohexene. 1 cyclohexene. And there are 3 and 6 position of the carbon atoms. So this is the one if you are going to use it. This one if you remove the double bond, then you have to start from nearest. One, two, three, four. 1, 2, 3, 4. Same distance. 1, 2, 3, 4, 5, 6. This will be a 1, 3 cyclo. 1, 3. Okay. Dimethyl cyclohexane. 1,3-dimethyl cyclohexane. So these are the cyclic compounds, maybe saturated, maybe unsaturated. Physical properties like alkanes, low polarity of the cycloalkanes also. Intermolecular forces between the molecules of cycloalkanes are very weak due to the carbon-carbon bond. There are the London dispersion forces between the carbon-carbon bonding, like alkanes, low melting point and boiling points. Cyclopropane, cyclobutane, cyclopentane, cyclohexane, cyclohexene. Similar reactivity close to the alkanes due to presence of sigma bond, carbon-carbon bond and carbon-hydrogen bond. So cycloalkanes like alkanes are not very reactive to the acids and also oxidizing agents. Similar very close reactivity with the alkanes. What are the polar? I told you polar bonds are partial positive, partial negative, just like alcohol and also glucose, sugar, amines. Non-polar, they are carbon-carbon and carbon-hydrogen bonds. Isomers, the organic compounds having the same molecular formula but different in the structural formula are called isomers, and the phenomena is called isomerism. Butane has the two isomers, N-butane and isobutane. What are the inert, non-reactive compounds? Paraffins. Alkanes are inert to the acids and alkalis and oxidizing agents. What are the intermolecular forces and intramolecular forces? So dear students, intermolecular forces are present between the two molecules. Just like there are two molecules of hydrogen chloride. This single straight line is called covalent bond. This is between hydrogen and chlorine, and I told you this is a polar bond. This is also polar bond. This is between hydrogen and chlorine by using single covalent bond by mutual sharing of electron pairs. This is a mutual sharing. So if the bond is formed by mutual sharing of electron pairs between the two atoms, this is called intramolecular force. So covalent bond is the intramolecular force between the two atoms of one molecule. This is the intramolecular force. Also this one. Intra. This is also between hydrogen and chlorine. Differentiate I have given you by the broken lines. This is also between hydrogen and chloride, but this bond is not formed by the mutual sharing. This bond is formed, this force is formed by the partial positive charge and partial negative charge due to the difference of electronegativity. Attractive forces due to the polarity. These forces due to the sharing of electrons. There is no sharing of electrons between this chlorine and this hydrogen. This type of bond is called intermolecular forces. This bond is called intermolecular forces. So, the bond which is bonded between the two molecules by not sharing, only due to the difference of their electronegativity's polarity. This force is called dipole-dipole force. This force is called dipole-dipole interactions, dipole-dipole forces. This force is called covalent force, polar force. This force is called covalent force. This is the difference between the intramolecular force and intermolecular force. Then I will give some introduction about this topic. 16.3 article, radical substitution reactions. Radical substitution reactions. Radical substitution reactions. Overview. Substitution of alkyl hydrogen. Alkyl hydrogen means methane. This is the alkyl CH3 and this is the hydrogen. Alkyl hydrogen with halogen. Why halogen? Halogen. Like this. So this become alkyl halide. This become methyl halide. Hydrogen is substituted. Hydrogen is substituted. So this hydrogen and hydrogen, there is a, you will find the hydrogen also the one, you will get a hydrogen halide. So this is called a substitution reaction. One atom replace, substitute other atom. This halogen substitute this hydrogen. Take place, this halogen will become and this halogen will go. So these reactions are called substitution reactions. Now alkanes reactivity order, third degree. Reactivity order of alkanes. Third degree alkane is more reactive than second degree. Second degree alkane is more reactive first degree. And first degree is more reactive than methyl. When more substituent groups attached with the longest chain, this is called more alkylated alkane. More alkylated, more alkyl groups are attached. So dear students, if the two groups are same carbon atom, this is tertiary. Neo 1, 2, 3, 4, 5. Neopentane. Or 2,2-dimethyl propane. So this is the third degree. Two carbon atoms are attached the same carbon. More alkylated. This is the third degree. More reactive. Then second degree. Like this one. Or like this one. And first degree, A1. Like this one. Ethyl will be like this one. And methyl is CH3. So, reactivity order, third degree, second degree, and first degree means methyl. This is the first degree methyl, same. Both are same. And second degree and third degree. So this methyl means one carbon, like this one. This is the first degree. One only. Iso, we call iso, we call U, we call M. Ethyl, methyl, propyl, butyl, N. One carbon. They are the one branch. Two branches, this is more rings. There are two more carbons. And here at the same carbon there are two, this is Leo. This is called third degree. And this is called a second degree. And this methyl or ethyl, they are called first degree. Then halogen. For the halogen, fluorine. Molecule then chlorine, molecule then bromine, and molecule then hydrogen. This is the reactivity between the halogens. Only chlorination and brominations are used in the laboratory because fluorine will give explosive chemical reactions with alkanes. We don't use in the laboratory. Highly reactive, explosive. Iodine is least reactive. No, means non-reactive, no reaction at almost no reaction. That's why most reaction, dangerous chemical reaction, and almost no reaction. So we use these two moderate, fluorine and bromine. Yes. Reaction proceed via radical chain mechanism. This is our radical substitution of the reactions. And here is interesting information about how the arrow is going to be explained by this one. So dear students, there is a chain reaction, how the attacking of one group to other. So you can see on the page number 118. So we use curly arrow. There are two types of curly arrows. Two-headed arrows, full arrow, half arrow. This is a half arrow, this is a full arrow. So two arrows are going to be used for attacking. Curly arrow is sometimes used to show the movement of the pair of electrons. Means you can see in the first one, bromide, one electron pair is going to shift, move from negative to carbon positive. Half curly arrow is shown here. And if the one full pair of electrons between the carbon and the bromine is going to be shifted, then full curly arrow is used. For the bromide, same pair, same electron pair. And for the carbon and bromine, they are the bond between the carbon and bromine by the electron of carbon and bromine. So this two different electrons pair are going to be shifted. So this is shown by the full curly arrow. So you can see this one. Between the hydrogen and chlorine bond is going to be cleavage. Hydrogen and chlorine, there the bond is going to be formed, and between the chlorine and chlorine, the bond is going to be dissociated. So these arrows, curly arrows, show the movement of electron pair. So electron pair starts here, and here. This is the full and this is the half. Curly half arrow shows the movement of single electron unpaired, and full curly arrow shows that paired is going to be shifted bonded electrons. But inshallah next lecture I will explain this mechanism whole. So students, this is very important, and also because we will do the mechanisms of the chemical reactions. So these curly arrows help us how to the movement of electrons taking place, either paired or unpaired, bonded or non-bonded electrons. So thank you very much. If we stop here.